Good morning. While he's fixing my slides, it's 6 o'clock in the morning in the US. You can imagine I should be that tired, but I'm surviving. So I would like to thank you for being here. The reason is I travel worldwide and give these speeches. Each time there is a president or vice president or a minister, the hall is completely full. And after he leaves, 2/3 of the people leave. So I was scared that when this minister was here, that you will all be gone. I will have 50 people, but this hall is full. Thank you. Thank you. So that shows that you are very interested in IoT, and I hope I can, there is this noise in the back. Please, if you want to talk, you're welcome to go outside. Did you hear? Hello? Respect, please. So I also would like to thank the organizers, Imad, and also Farouk, Professor Kamoun, who is a longtime friend. So I'm extremely happy to be here for the 4th time. So the first two were many, many years ago in 1981 in Zarzis, and I found out Fethi is from Bangardin. So I was a young fellow at that time and hippie, and I ended up there, right? So let's go to the Internet of Things, and I have 30 minutes. So there are so many things to say. Yesterday I presented you the micro things, nano things, and bio nano things, and today I will be more focused on the micro things and also more business issues. So hopefully you will get some ideas from this presentation.
Use the clicker.
Oh, which one? Here? Yeah, okay. Good. So what is Internet of Things? I'm sure you know that already. Which one is the
right, this one.
No, the pointer. This one?
Yeah.
Good. So now I do like yesterday, this guy. So Internet connects all people. So we call it kind of like Internet of People. And IoT connects all things, Internet of Things. Also, Cisco calls them Internet of Everything, as you know. So the simple definition, there are many, many definitions. So the simple definition, as I also mentioned yesterday, interconnection of things, objects or machines. What can they be? Anything you can imagine, sensors, actuators, mobile phones, electronic devices, home appliances, anything you can imagine, any item, anything goes. So they are connected to each other, and they use Internet as backbone and communicate with each other, as you see on this picture also. So the Internet of Things, it's really growing exponentially. When you look at this picture in 2003, we had more humans than the machines or things, as you see here, the blue one. In 2010, the things exceeded the humans, and 2015 more, and by 2020, we will have 50 billion things connected to each other. So many more than the humans. Some of you may know that 5G systems are already in the planning. So we are thinking about 2020, 2030, we will deploy them. So the IoT will be a major part. So if you want to play a big role in 5GPP and 5G systems, you can also go through the IoT track. So they are talking about connection of 7 billion people and 7 trillion things. So you can imagine this size of these networks. So major characteristics of these IoTs are very large scale, or actually ultra large scale, right? And heterogeneity, because we will have many, many devices from different vendors and highly heterogeneous environment. And pervasivity is computing and communication technologies will be embedded in our environments. So there is this 4-layer model of IoT, because some people always confuse IoT with the sensor networks or RFIDs. It's not. IoT is the big umbrella. It covers all of them. As you see here on the bottom one, you can have GPS, smart devices, RFIDs, sensors, anything you can imagine. That's the sensing and identification level. And the backbone, you can have network construction, any network physical network can support this, like, internet, wireless, WiMAX, or, metropolitan area networks, anything you can imagine, they will be supporting these devices. And then the information processing, we have data centers, search engines, smart decisions like machine learning, right? All these algorithms, security mechanisms, and data mining solutions will be on this level. And then tons of applications. Like today, we have seen a bunch of young people. So we have like, some of them are here, like logistics and smart grids and green buildings and smart roads, all of that. So you can have many, many of that. Same thing here. By no means these layers are complete. They are just showing the examples how the entire big umbrella of IoT looks like. So everybody talks about Internet of Things outside terrestrial, right? But there are more, by the way. So what about Internet of Underwater Things? So I also did research for Navy for many years. So you can create all these devices under the water, and then they can use the backbone, and you create another Internet of Underwater Things. Or Internet of Underground Things for agriculture, for example, or also soccer field, tennis field. There are many, many applications for the underground things. So it's a big business also, by the way. So this is a new initiative in the United States. They are just trying to get proposals from the US Army. It's called Internet of Battlefield Things. Okay. Then here is another thing, Internet of Space Things. I was visiting University of New Mexico. They have Air Force Research Lab there too. So they showed me that they have this, I mean, it looks big, right? But they are like mug size, mug, coffee mug, right? So they have these big, small satellites and large network in the space, and then they will cover also the satellite communications. Here yesterday I talked about Internet of Nano Things. They are much more powerful, and I explained to you all yesterday. If you missed it, then it's okay. Then this is Internet of Bio-Nano Things. So you can put them all inside the body, and then you can initiate these artificially designed machines. And so you can get all the information from the inside the human body. Why can we use it? For e-health, for example. You can detect bacteria, infectious diseases, for example, Alzheimer's, all of the above. So it will also prolong our lifespans. Again, yesterday I talked about it. So the Internet of Things perspective, we are talking about anytime, any place, anything. So anytime is on the move, outdoor, indoors, and night, or anytime. And any place, outdoor, indoor, on the move. And then anything is human to human, human to things, and things to things communication. So they can support any communications, anytime, any place, anything, as you know. So there are these top industries key for IoT applications. Again, some of you also have seen this example about smart grid, mini one here, smart health, smart homes. So the list is long. So you can, everything will be smart, and then all these things will be connected to each other. That's the bottom line. Okay. There are some IoT products, and by the way, unfortunately, maybe it's luck for all of you or us, that the market is not there. You will see it. So it will increase, but all these products are doing okay, but it's not like billion-dollar industry so far, right? So there are also these IoT platforms by the big companies like General Electric's Predix, Cisco IoT Cloud, IBM Watson IoT Cloud, and PTC ThingWorx platforms. Mostly, they are really going more futuristic, looking for softwareization, cloud, software-defined networking, slicing, function virtualization concepts. Then you will see it. General Electric Predix was introduced in January 2006. It used the platform as a service model and is cloud-based operating system and built on the so-called Cloud Foundry, and which is open source platform. You can put any applications you want in that platform. And also it's optimized for secure connectivity and analytics at scale. It's very important, data analytics in this concept. I will also mention this to you later. And so they take care of that. Cisco IoT Cloud is, again, it's sitting on 6 pillars. Network connectivity, fog computing or edge computing, data analytics, security. Security is the biggest problem, or one of maybe the biggest. Management automation and application enablement. IBM Watson case, it's again based on Cloud Foundry and OpenStack. It's always open architecture, right? Software, open software. And Watson IoT platform development, it connects all the sensors, the cloud application using so-called IBM Blue Mix. And then the PTC things works. It is capturing 27% of the market. It has 3 pillars: core application enablement, connection service with device and cloud adapters, and edge connectivity using the edge microserver and edge always on devices, which is going to edge computing and fog computing. So these are the platforms that you may use. And I will not go all the details about applications. Smart home, you can see here, like electricity control, air conditioner control, anything you can imagine for safety. Then healthcare, this was also discussed today partly. So here is the healthcare has a lot of money, by the way. But I explained yesterday, as Tunisian IoT or IT technology, you cannot compete with the Huawei or Europeans and Americans. So what you need to do is you have to focus on, for example, Arabic market. There are 600 million people. So tailor everything to this domain so that you can make maybe money. So here you can see here, it's expected from $32 billion in 15 to 163 billions by 2020. So these are the predictions in the healthcare. Transportation is also important for safety, efficiency, and sustainability. It will save lives and properties, reduce emissions, meaning protect environments, and also cut commuting time and efforts, as well as fuel consumptions, right? So it will also reduce our expenses. So you see also the cars they already have many sensors, but they will be built, they will have tons of sensors, plus there will be 1 million lines of code in some of these cars for the car-to-car communication, car-to-backbone, like I'm talking about vehicular communication systems, right? So now intelligent transportation, it will also help us like driver warning, autopiloting, etc. So smart grid is very important. So there will be a use for these. Here is a smart grid market from China. From total $20 billion, we are talking about jump to the $2 billion with alone smart meters. So smart meters is part of smart grid, as you can imagine. So now let's talk about what are the trends spending for IoT solutions, okay? So worldwide, these are really brand new results, by the way, information. There is still this noise in the back, please. Good that I'm not in the theater, an actor, I will be always, anyhow. So worldwide IoT market will grow from 655 billions in 2014 to 1.7 trillion in 2020, with a compound annual growth rate of 17%. IoT analytics market, data market, is estimated to grow again at compound annual growth rate at 27.5 to reach $16 billion by 2020. So we are talking about really big money here, right? Total service spending, service meaning consulting, right? Professional consulting, consumer connectivity services, or services, you can say that. It will reach $482 billion by 2020. And IoT market in manufacturing operations will grow from 42 in 2013 to almost $100 billion in 2018. So global spending on retail and IoT initiatives is expected to grow to 15 billion in 2015 and 35 billion in 2020. Okay. So here is this again the IoT connectivity competitive landscape. So we have these extremely low data rate and higher data rates and very low distances, as you see here. But then these are all known to us, Bluetooth and Zigbee 802.15.4, and then 802.11ah. So they have reasonable medium distances and also reasonable data rates. But we are also talking about long range, wide area networks like LoRa. 3GPP is talking about for 5G developments, and then 5GPP will take over. Like Sigfox, these are the existing solutions, but many problems. I have to warn you also. When these people come out with, if they are company people, please accept my apology after 35 years in this business. They tell you the world, promise everything, but then when you get in, then you say, oh my God, there are a lot of things. And then they come in the version 2.0 will take care of that. I mean, that's the business. Yeah? They need to make money. Nothing's wrong with it. So 3GPP standardization for IoT, they are talking about category M device for LTE. Then also this is hot topic, narrowband IoTs, and also extended coverage GSM. So now you can see this is the picture for, this is today, LTE Advanced or LTE Advanced. This is more like we are trying to improve performance and mobility. And we will also try to, in the future, to reduce the complexity and also power consumption, plus extend the distances, coverage areas, and also accordingly capture more applications. So what are the major obstacles, right? This is still not $1 billion. I mean, you saw the numbers, but sometimes they're also elevated, okay? So don't take that exact numbers. So that's business world. Imad may know that, okay. So here, major obstacles for IoT deployments. High cost of, by the way, these are the priority list, okay? The top one are the highest priority, and then it goes lower to the lower priorities. High costs of required investment in IoT infrastructures. Concerns about security, privacy. Lack of senior management knowledge and commitment. Weaknesses in organizations' technology infrastructure. By the way, these are worldwide, not just, USA. Regulations, like standardization, that's one part, relating data privacy, but there are many other regulation problems. Weaknesses in public communication infrastructure available to organization. Immaturity of industry standard around the IoT, general economic uncertainty, undeveloped consumer awareness. That's really important. You have to understand what consumers need. That's why I also mentioned yesterday, you have to find out what is the Arabic world needing, and we can develop that here in this country. Absence of business case and business models. Okay. So what measure the company is taking to use the IoT more extensively in the business? Again, highest priority going to the lowest priority, okay? Seeking advice from third-party experts and consultants. Learning from the successes or failures of early movers. Training existing staff to work with the IoT. Conducting or sponsoring research to establish market size and demand. Establishing a cross-functional task force to explore and or pursue IoT opportunities. Introducing new business models. Raising fresh capital to explore IoT options. You need investors, right? Also, sponsors. Hiring talent with IoT capabilities. Many universities still don't teach these, IoT per se. establishing joint ventures or alliances to exploit IoT opportunities, establishing an IoT center of excellence, not just one. You can do that here too, for example. Center of excellence in IoT in Tunisia. Acquiring a business or assets with IoT capabilities. So these are the business versions. What are the things, trends to watch in the future? You can also become a service company or IoT. It's called IoT services, business consulting. That's major driver. You don't need to always have infrastructure and deploy everything, right? That will be a good market for a lot of people. Then data, so much data will be collected. We need to find out the most efficient, optimum data analytics solutions. Because data must be managed, filtered out, integrated, analyzed, and then we need to make sense of this collected information. And IoT is really getting more and more into this cloud and softwareization. So we need to also find ways of doing that. And also, IoT data, there will be a new market as data brokers. So that could be another business model. That means IoT generated data, it can be collected and can be sold to other companies. As an example, IBM bought the weather company data. So that company did a lot of money through that, right? It's a data broker. And there are interoperability problems. I will also mention this in the standardization problems. And of course, the most important one is the security. So this is not the prioritized, by the way. So the security is the last one, but the most important one. So research challenges, we have so many papers on sensors and RFIDs and, you name them, 300, 400,000 papers. You cannot use almost any of them, really, because they are not scalable, all this routing and all these MAC protocols. So we need scalable solutions. How do we deal with the massive number of devices? Not only massive, but also heterogeneous, right? Security, privacy, Vint just mentioned about this. Safety, authentication, denial of service attacks to those devices. Interoperability again. Again, how do we handle the data that we will be collecting of these billions of devices, right? So, we need gigantic data centers. Maybe before they come, we will filter them out, calibrate them, aggregate, fuse the similar data, and then get them into these data centers. Reliable coverage. I mean, good luck with the utility companies. 2004 until 7, I had work for Smart Grid. They are extremely conservative. They will not apply wireless communication because they say, I cannot trust my substations for some 1% or 0.5% failure, because it's like death situation sometimes, right? So, we need reliable coverage if you want to do wireless. Move cloud services to the edge of the network, fog computing. Reduce data to be stored. That's another, finding better storage techniques or processing capabilities. Power consumption problem, energy harvesting, software optimization or softwareization, and SDN and FE-based IoT. And, So I just mentioned to you SDN and FE. In case you never heard of it and you are still in networking communications, please get there, really. So, because you will see 100,000 papers again in the next 5 years. So most of the research was done for the wired networks the last 10 years. So the idea is take, just simple idea without looking at the figure. The idea is take the entire software from the switches, put them to cloud or so-called controllers. Please do not mix controllers with the clouds. So the controllers are devices. For example, Huawei, Cisco, Intel, they all produce controllers. They're pretty expensive, by the way. So they have basic software, but then it's an open architecture. You can develop your own software or purchase other software and put it up there. So that's the open architecture. It really supports innovation. So that's the beauty of these controllers. But there are so many problems because the controllers, or one controller or multiple, they will be the brain of this entire network. The underlying switches will not have anything, just bare bone hardware. So the brain will always tell, do this, do that. So there's a lot of signaling between the controllers and the switches. And now we are moving to the 5G. All the base stations will be called remote heads or remote radio heads. Same thing, all the software from the base stations will be moved. We call them baseband servers, like data centers, as you see here. So all the software will be here, again, open architecture, and they will be coordinating these base stations because they don't have anything to coordinate. So these are the sub-brains. This is the upper brain. This is the backbone, brains. This is the backbone here in this back. So, and then, now we are coming to the IoT, right? IoTs will have the same thing. So, by the way, these are all under development now, so the concepts. So you can have another third level of controllers here. Again, pull out all the software from the sensors because they need a lot of energy, right? Energy consumption. And then also they will be just simple hardware. And actually you can do that, right? So these software will be sitting in these subcontrollers, and then the subcontrollers will tell to sensors what to do. And by this way, you can also solve the scalability problem. But again, please, we have a paper on this 5G challenges, so you can read a lot of details about this. This is brand new thing, as I told you. So everybody was looking at the backbone. Now the 5G people start to look at the base stations. There are very, very few people looking at the IoT domain. So I hope I could give you some ideas. Then more challenges, standardization, interoperability is really a big problem, right? And also when you use cloud-based software, SDN-based systems, you cannot wipe out the legacy systems. They have to work together, right? So how will we do it? And you can say, oh, we'll just put a gateway. That doesn't solve the problem, right? So heterogeneity of sensors and interfaces to cloud servers. Again, the standardization is not there. Like 802.15.4, Zigbee, it's a joke, really. I mean, when you know the subject, they are having these simple-minded tree architectures, simple-minded number of devices. So we really need a standardization body which can help this, IoT problems. Oops. I think that's it. Thank you.